I'm Jamil, Economy Wala, and I hope you all are doing well. Today, I bring Maya to discuss my today's really important topic with him and to learn from him about your topic. And today's my important topic is how does artificial intelligence learn from data? And like we all take help from artificial intelligence in our all works in our everyday's work. So that's why I choose this topic that how artificial learn from data. So let's get dive into the this call. Hello Maya, how are you?
Walaikum assalam. And hello to you too, Hesham. Good to be in the Leaders Lounge. I'm doing well. Thank you for asking. And that's a sick topic. How does artificial intelligence learn? It's a big question, huh? But a really important one.
So Maya, now we have to start our today's podcast. And to start, I have some basic questions and to understand it. So first of all, Maya, can you tell us that what it means for AI to learn from data?
Okay, great starting point. So when we say AI learns from data, it's not quite like how humans learn. Build on past experiences, things emotionally. AI is more about spotting patterns. Essentially, you feed an AI system tons and tons of data. Images, text, numbers, whatever. And it uses algorithms to find relationships and make predictions based on those patterns. It's kind of like teaching a kid to recognize a cat, but instead of saying, that's a cat, AI identifies recurring visual features, pointy ears, whiskers, a certain shape, and eventually reliably identify cats in new images. Does that make sense as a basic starting point?
Yes, Maya, that makes sense to for basic starting point. So thank you so much for explaining. So Maya, now can you tell us that um, how does supervised learning different from unsupervised learning?
All right, dive me a little deeper. Okay, so think of it like this. Supervised learning is like learning with a teacher. You give the AI labeled data, meaning you tell it exactly what everything is. This is a cat. This is a dog. This is a bird. The AI learns to associate those labels with the data. Unsupervised learning, on the other hand, is like giving the AI a pile of stuff and saying, figure it out. There are no labels. The AI has to find the patterns and groupings on its own. I might notice that some images have similar colors or shapes and group them together, but it doesn't know what those groups represent. It's up to us to interpret what it found. Supervised is about prediction, unsupervised is about discovery. Does that distinction
Yes,
just
Maya, this clears my distinguished. Thank you so much for explaining it. So Maya, now can you explain that what role does label data play in machine learning?
absolutely?
Because I also listen about the data learning. So data play, label data in the machine learning. So what is the role of label data in machine learning?
You're right to focus on level data. It's huge. Basically, labeled data is the fuel for supervised learning. It's what allows the AI to actually learn to make accurate predictions. Think back to the cat example. Without someone labeling the images as cat, the AI would just see a bunch of pixels. The labels give the AI a cursor to compare its predictions against. The quality of the labeled data is super too. If the labels are inaccurate or inconsistent, the AI will learn the wrong patterns. And it's often a really time-consuming and expensive process to quality labeled data, which is why it can be a bottleneck in machine learning projects. It's a bit like a student needing a good teacher and accurate textbooks to learn effectively. Does that help clarify the role?
It's Matt helps to us to clarify the role of label data in machine learning. Thank you so much for explaining it. So Maya, now my next question is also an important question that how do algorithms identify patterns in raw data?
Happy to
because
help
it's
Claire?
hard, really hard.
You're right, it is hard. It feels almost magical, but it's all down to math. Algorithms use statistical techniques, things like decision trees, neural networks to find those patterns. They're basically looking for coordinates, relationships, and trends in the data. Think of it like sorting a huge pile of list size and shape. The algorithm is doing something similar, but with complex data and many more variables. Neural networks, which are inspired brain, are particularly good finding complex patterns, but they require a lot of data and computing power. It's not about understanding the data in the way a human does, but about finding mathematical relationships can be used to make predictions. Does that make sense? Or would you like me to break it down further? Can get pretty technical quickly.
Uh, yes, Maya, you're totally right. It is pretty technical. So I want to like, if you explaining in more and go to dive deep dive, so then it will be easy to understand for us or on all for my viewers. Please, can you explain more about it?
Deep dive in, let's talk about neural networks, since those are really powerhouse on an AI. Imagine a network of interconnected nodes organized in layers. That's a simplified neural network. Each connection between nodes has a weight assigned to it, its importance. When data flows through the network, each node performs a simple calculation, and the results are passed on to the next layer. The network learns by testing these weights. It starts with random weights, make prediction, first that prediction to the correct answer. Based on difference, it adjusts the weights to make better predictions in the future. This process is called backpropagation. It's like tuning a radio. Adjust the knobs until you get a clear signal. Each knob is weight, and the clear signal is the accurate prediction. The more data the network processes, the more accurately it tunes weights, and the better it gets at identifying patterns. There's different
Yes.
types of neural networks, each designed for different tasks. Convolutional neural networks are great recognition. Recurrent neural networks for processing sequences like text or speech. But the basic principle is the same. Layers of interconnected nodes learning by adjusting weights. It's complex, but hopefully that gives you a slightly clear picture of what's going on under the hood.
Yes, Maya, you're right. It's like it's long and it's really hard. But can like it is easy for the algorithm identify because it is made by AI. It is bec- by the help of AI. It is like easy. So now my next question is, what are the basic steps involved in training an AI model?
You hit the nail on the head. It's hard for us to grasp, but the algorithm just crunches the numbers. Okay, so the basic steps for training an AI model are pretty consistent. First, gather and prepare your data. Labeling it, and is used to tune the model settings, and the test is used to evaluate its performance. Then you choose an appropriate algorithm and define a loss function. This measures how well the model is performing. Next, you feed the training data to the model, and it adjusts its parameters to minimize the loss. It's the learning process we discussed earlier. You repeat this process many times, iterating over the data. The model's performance reaches a satisfactory level. Finally, you evaluate the models on the testing set to see how well it generalizes to unseen data. It's an iterative and refining. Kind of like ride a bike, you fall a few times, adjust your balance, and eventually you get.
Okay, that's nice. Thanks so much for
Just checking if that
okay, so much for explaining. So Maya, now we have to
you're
data
very
collection and pre-processing. So Maya, can you tell us that how important is the quality of data in AI learning? I think it's most important.
You are absolutely right to say that. It's not just important, it's the most important thing. Garbage in, garbage out, as they say. A model is only as good as the data it's trained on. If the data is inaccurate, incomplete, biased, or inconsistent, the model will learn those flaws and make flawed predictions. Think of it like cooking. Even the best chef can't make a delicious meal with rotten ingredients. Data cleaning and pre-processing are essential steps to ensure the quality of the data. This includes handling missing values, correcting errors, removing outliers, and transforming the data into a format that the AI can understand. That's often a tedious and time-consuming process, but it's absolutely crucial for building a reliable AI model. It's honestly where a lot of the work happens, far more than the actual algorithm selection sometimes.
Okay, that's it. Like, it is like one of the most important thing in the AI learning, right?
Exactly. It's the foundation everything else is built on. You can have the fanciest, most complex algorithm in the world, but if you feed it bad data, you're going to get bad results. It's like building a house on a shaky foundation. Eventually, it's going to crumble. You've got a really good grasp of this concept, by the way.
Okay, thanks so much for precious appreciation. So, but now can you tell us that what are the some challenges in data processing, pre-processing? Sorry.
Oh, there are plenty. Data pre-processing is rarely smooth sailing. Some common challenges include do fill it in, remove it, or use a more sophisticated imputation technique. Dealing with inconsistent data formats, dates, addresses, names can all be represented differently. Identifying and removing outliers. These can skew your results. Correcting errors and typos, this can be surprisingly difficult, especially with text data. And then there's data bias, ensuring your data accurately represents the population you're trying to model. It's a bit like you have to piece together the data, clean it up, and make sure it all fits together correctly. It requires a lot of careful attention to detail and a bit of detective work.
Okay, that's great. Okay, so Maya, now can you tell us that how is feature engineering used to improve model performance?
All right, feature engineering. This is where it gets really creative. Essentially, feature engineering is the process of transforming raw data to features that better represent the underlying problem to the predictive models. Instead of just feeding the algorithm the raw data, you create variables that might be more informative. For example, if you're predicting house prices, instead of just using the square footage, you might create a feature for footage per bedroom or distance to the nearest school. It's about using your domain knowledge to create variables that the model can easily learn from, can drastically improve model performance, but also require a lot of experimentation and intuition. It's almost crafting the perfect ingredients for a recipe. The right combination can make all the difference.
Yes.
Glad that makes sense. It's a bit of an art as well as a science. It's where you really start to leverage your understanding of the data and the problem you're trying to solve.
So hey,
Just
you're right.
checking in.
Uh,
Yes, I'm good.
it was pleasure with me, and you're also very accurate. Thank you so much for all the explanation. So Maya, now can you tell us that how do you deal with missing or inconsistent data? If anyone asks you any question, so if you didn't have any information about it, so then what do you do?
That's a great question and a really important one. It's true. I don't have access to external databases or the ability to look things up in the same way human does. When faced with missing or inconsistent data in a conversation, I try to be transparent about it. I'll usually say something like, "That's a good question, but I don't have information about that specific topic." Or, "I wasn't trained on the data set." I can also try to reframe the question or ask for more context to see if I can provide a helpful answer based on what I do know. I'm designed to be a conversational partner, not an encyclopedia. It's better to admit my limitations than to provide inaccurate information.
Okay, okay, I understand it. Totally understood what you want to ask, and I know like what you did, how do you deal with this thing or personal data. So now my question is that how does one choose the right algorithm for a specific problem?
That's the million-dollar question. Choosing a right algorithm is crucial. There isn't a one-size-fits-all answer, unfortunately. It depends on a few key factors. The type of problem you're trying to solve. Is it a classification problem? A regression problem? Something else? The type you have. Is it numerical, categorical, or images? The size of your data set. Some algorithms require a lot of data to perform well, only the desired level of accuracy and interpretation. For example, if you need a highly accurate model and care about understanding how it makes its predictions, you might choose a complex algorithm like neural network. But if you need a model that's easy to understand and explain, you choose a simpler algorithm like a decision tree. They'd often experimenting with different algorithms and comparing the performance. It's a bit like trying on different until you find the pair that fits just right. Does that give you a good view?
It's right that gives me a good review. So much for it. And now my I am questioning you firstly because I don't have enough time for all the my pending questions because I have much questions on this topic and time is very short. So now can you tell us that what is overfitting and how it can be prevented?
Sounds good. I understand completely. Life happens, and it's an important topic. Overfit. I'm glad you're covering it. Definitely happy to pick up this conversation another time. When you am with, let me know when that might be. Just wanted to check if you were still there. No need to respond if you're wrapping things up.
My question was that what is overfitting and how it can be prevented?
My apology. I jumped the gun thinking you were finished. You are absolutely right to circle back to that. Overfit happens when a model learns the training data too well, starts to memorize noise and specific details instead of learning underlying patterns. This means it performs the training data but poorly on new unseen data. To prevent it, there are several techniques. One point, more data, the more data, the better. It forces the model to learn general patterns rather than memorize specifics. 2. Correlation. This involves splitting your data into multiple sets and training and testing the model on different combinations of those sets. 3. Regularization. This adds a penalty to the model for being too complex, encouraging it to learn patterns. 4. Early stopping. This involves monitoring models' performance on a validation set and the training process when performance starts to decline. 5. Simplifying model. Sometimes the best solution is to use a simpler model with fewer parameters. It's about finding the right balance between complexity and generalization. Does that explanation make sense?
Thank you so much for explanation. The explanation makes sense, Maya. Thank you for all the explanations of my questions and for all the answers. So Maya, now can you tell us that how can base data affect AI learning outcomes?
You're very welcome. And yes, explanation is always good. Okay, so how biased data of AI learning this is used. Bias data leads to biased AI. If the data used to train an AI system reflects existing societal biases like gender, racial, or socioeconomic biases, the AI will perpetuate and even amplify those biases. That can have serious consequences, leading to unfair or discriminatory outcomes. For example, a facial recognition system trained primarily on images of white faces may perform poorly on face color. A hiring algorithm trained on data from a male dominated industry may discriminate against female applicants. It's really critical to be aware of these biases and take steps to mitigate them, using techniques to detect and regularly auditing AI areas. It's not just a technical problem, it's an ethical one too. Just checking. Still there? No worries if you're wrapping things up, to be sure.
No, Maya, I'm still here. I'm not going to wrap up anything, but my mic was muted whilst I was speaking. But my mic was muted, so sorry for that. So, Maya, now can you explain that how can we make AI models more fair and transparent?
Ah, that explains the silence. No worries at all. Happens to the best of us. Okay. Making AI models more fair and transparent is a huge area of research right now. A few things can be done. First, diverse and representative data sets are key. Ensuring that the data used to train the model reflects the diversity of the population it will be used on. Second, bias detection and mitigation techniques can be used to identify and correct biases in the data and the model itself. This can involve techniques like reweighting the data or using adversarial training. Third, explainable AI or XAI techniques can be used to help understand how the model makes its decisions, making it easier to identify and address potential biases. Finally, regular auditing and monitoring are crucial, continuously evaluating the model's performance for fairness and transparency over time. It's not a one-time fix, it's an ongoing process. It also involves bringing diverse perspectives into the development process. People from different backgrounds are involved and evaluate these systems. Still with you. Just letting you know, I'm listening, even with the quiet moments.
Yes, ma'am. I am also listening to you. Listen to your answers. So, Maya, now I have to short time. I just had 3 minutes for my other questions, and now I think it can't be continue. We can't cover the whole the questions. So now we have to end the interview. So, what advice would you give to young researchers entering the field of AI learning? And advice should be long, for almost 3 minutes. Then we will end our interview. And should be detailed to advice.
Okay, 3 minutes! That's a good time frame for some final thoughts. For young researchers entering the field of AI learning, first, curious. This is a rapidly evolving field, so a thirst for knowledge and a willingness to explore new ideas are essential. Second, embrace interdisciplinary thinking. AI isn't just about computer science. It intersects with ethics, sociology, and many other fields. The best solutions often come from combining insights from different disciplines. Third, focus on building ethical and responsible AI. Think critically potential impact of your work and strive to create AI systems that are fair, transparent society. Don't be afraid to ask difficult questions and challenge the status quo. Fourth, collaborate. AI is a team sport. Seek out opportunities to with others, share your ideas, and learn from different perspectives. Don't be afraid to fail. Research, trial and error, learn freaks, and keep pushing forward. It's an incredibly exciting field. I'm excited to see what you all will accomplish. It's a real pleasure chatting with you today.
And okay, thank you so much for really nice advice, really helpful advice from the viewers. And here I want to add one thing that mistakes are the proof that you are trying. So it's not really like you are mistaking, you are making mistakes. Mistakes are the proof that you're trying, and try it again. One day you will become successful. So so thank you so much, Maya, for giving precious time and all the answers of my questions and very nice advice from my viewers. So viewers, this is today's my interview with Maya. I hope you all enjoyed it and learned a lot from it. So see you next time with Neil Sport with Maya. Till then, Allah Hafiz. In and as always, Pakistan, Zindabad. Take care, all of you. See you next time. Allah Hafiz.